Assalamu alaikum and good day, everyone. Today, I will be presenting about spatial data analysis, focusing on the concept of interpolation, the tools used, and their applications in GIS. This presentation aims to help us understand how spatial analysis is used to examine geographic data and produce meaningful information for decision-making. By the end of this presentation, you should be able to, first, understand the concept of spatial data analysis. Second, apply basic spatial analysis tools in GIS. And third, identify common spatial analysis techniques used in geographical studies. Definition of spatial analysis. Spatial analysis is the process of examining the locations, attributes, and relationships of features in spatial data. It helps us understand patterns, trends, and connections between geographic features. Through spatial analysis, we can answer questions and gain useful knowledge from geographic data. Tools and function. There are several interpolation tools commonly used in GIS. These include natural neighbor, trend, IDW, or inverse distance weighted, topo to raster, kriging, and spline. Each tool uses different methods to estimate unknown values and create continuous surfaces from sample data. Application and purpose. Data source. The data used for interpolation usually comes from sample points collected through field surveys, GPS observations, remote sensing, or existing databases. The quality of the interpolation result depends on the accuracy and distribution of the collected data. Examples of interpolation tools. This slide shows examples of interpolation outputs generated using different GIS tools. The first example is IDW, which estimates values based on nearby sample points. The second example is natural neighbor, which creates smooth surfaces using neighboring observations. These methods produce slightly different results, depending on the characteristics of the data. Next example presents the trend tool and the topo to raster tool. The trend tool is useful for identifying general patterns and broad changes across an area. Meanwhile, topo to raster is commonly used to create hydrologically correct elevation surfaces and terrain models. This slide shows the spline tool and kriging tool. The spline tool creates a smooth surface from the sample points and is commonly used for natural features such as rainfall, temperature, and elevation. The kriging tool uses statistical methods to estimate unknown values and usually provides more accurate results because it considers the spatial relationship between data points. Conclusion. To conclude, interpolation is an important technique in spatial analysis. It helps identify spatial patterns and distributions within a study area. It also estimates values at locations where no sample data is available. In addition, it uses point data to create a continuous surface that can be analyzed and visualized more effectively. That is all for my presentation. Thank you for your attention. If you have any questions or comments, I would be happy to answer them. Thank you.